Good day guys, this is your tutor engineer. Today we'll be doing a grade 12 exam question based on work and energy. So let's get on with it. A 5 kg block moves up an inclined plane AB at a constant velocity of 1,2 meters per second when force F is applied. So here is the block, and then here is the force, and then the velocity is going to be constant all the way until point B. The first question is saying calculate the magnitude of the force F if the power that is used to move the block up the inclined AB is equal to 57.6 watts. So this is the power. So from here we can easily calculate the force using the relationship between the power and the force, which is power is equal to force times velocity. So since the power we're given as 57.6, then we need to get the force. The velocity, remember it's 1,2. The velocity are given that the block is moving up at 1,2 meters per second. So I'll write a 1,2 here, and then from here I can divide both sides by 1,2. Then I'll get a force. So a force is 57.6 divided by 1,2, which is going to be 48 Newton. So the force here is equal to 48 Newton. Now the second question is state the work energy theorem in words. So the work energy theorem in words is basically based on this formula. So it's W net is equal to change in kinetic energy. So if you were to state that in words, you would say the net work done on an object by a net force is equal to the change in the object's kinetic energy. So yeah, that's it. And then when you go to 5.3, it says the blocks or the box moves now slides on the down the slope BC. And then the question is if the coefficient of kinetic friction for slope BC is 0.5, so that's a coefficient of kinetic friction, calculate the velocity at point C using the energy principles only. So we need this velocity here, right? So let me just give you a clue. So when the previous question asks you to state the work energy theorem, it directly means that the following question you'll have to apply that energy work energy theorem. So we'll have to apply this formula on question 5.3. So the first thing that you should be doing from here is to write down the formula of work energy theorems, which is W net. Okay, sorry, let me just correct this. W net is equal to change in kinetic energy, right? So the kinetic energy should be simple. The block is moving up by a speed of 1,2 meters per second until point B. So that means at point B we have an initial velocity of 1,2 meters per second, and then we need to get the velocity at point C. So using the formula of the change in kinetic energy, you'll have 1/2 mass is equal to velocity at C, which is the final velocity squared, minus velocity at B squared. So this is the velocity in question that you need to calculate. We already have the velocity at B. We have the mass of the object is 5 kg. Now what is the W net? Okay, for the W net, you'll realize that when the block moves down here, it's going to be moving down, experiencing the frictional force. Let's call it the FK force. And then obviously the other force is the normal force, and then here you'll have the weight. gravitational force. So these are the only forces that are acting on the block 5 kg. So when you're talking about the W net, we're interested in the force that is parallel to the surface BC. So in this case, you've got two forces that are parallel. You've got Fk, and then you've got the parallel component, which is Fg parallel, that is parallel to surface BC. So you're going to be focusing on these two forces. They will be forming the W net. So let's just say now these two forces are moving in the opposite direction. So okay, basically let's just do them. So you've got Fk multiplied by change in x, or you can say distance BC. So let's call this distance change in x here, all the distance BC, all the way from B to C. Let's call it change in x. So the formula, you write change in x multiplied by the cos of 180. Since the motion of the block is this direction and the force Fk is acting in the opposite of the motion, so that's where the 180 is coming from. So that's one part of the W net. The second part will be the parallel component of the weight, which is plus Fg parallel multiplied by the same distance change in x multiplied by the cos of 0. So the 0 degrees because the component Fg parallel is in the same direction as the motion of the block. So that's why I use the angle of 0 degrees. So I think that's it for now on the left hand side. So remember, on the right hand side you've got half mass Vc squared minus Vb squared. Okay, from here let me just start substituting. I need to get, okay, let's look at the unknowns that I have. I don't know about Fk for now. I can calculate Fg since I have the weight, I have the mass of the block, but I don't know about Fk. So remember that we're given the coefficient of kinetic friction. Let me just calculate the Fk from here for the sake of the space. Remember the formula, Fn is equal to, in fact, coefficient of friction times the normal force is equal to Fk. So I'll be using up this formula to get Fk. I have coefficient, I do not have the Fn. The Fn should be straightforward. Let me just work out the Fn, which is going to be acting against the perpendicular component of the weight, which I can call it Fg perpendicular. So let me just focus on this plane here. On this plane. So just imagine I've got my x-axis facing that way and my y-axis facing that way, which is parallel to the Fn and the Fg perpendicular. So using that information, let me just work out the Fn. Okay, sorry, let me just do it here on the left hand side for the sake of the space. I will say Fn, which is going up, minus Fg perpendicular is going to give me 0 since there is no movement in this direction. So the net force is going to be 0. Fn is going to balance the Fg perpendicular. So Fn is equal to Fg perpendicular, which itself is equal to mass times mass, which is 5 kg, times 9,8, and then since the angle 32 is going to be there, it's adjacent to Fg perpendicular, so I'm going to use cos of 32 degrees. Okay, let me just make it look good over there. Cos 32 degrees. So the Fn here would be 5 times 9,8 times cos of 32 degrees. So it's going to give me 41,55 Newton. Now that I know what is Fn, I can come back here on my formula. The coefficient of kinetic friction is 0,25 given. Then I've just worked out Fn is 41,55. That's equal to Fk. So that means Fk is going to be 10,338 Newton. So that's going to be my Fk. Now let me just go back there. I know what is Fk now. I can just quickly go back to this formula here and replace Fk by 10,38 multiplied by change in x. Okay, now let me deal with change in x again. Change in x is the hypotenuse side of a triangle. Look at this triangle. Okay, let me just change the color from here to make it easy for us. So I've got this vertical height 1,2 meters, and then I've got the change in x over there, and then I've got the angle 32 degrees. I can use my trigonometric ratio of sin of an angle to get the change in x, right? So I will say sin 32 degrees is equal to the opposite side, which is h is 1,6, divided by change in x, which is my hypotenuse side. So in this case, it means change in x is equal to 1,6 divided by sin 32. So this will give me 1,6 divided by sin 32. That will give me 3. Okay, it's just going to be 3 meters. Okay, now that I know what is change in x, I can replace it there by 3. And then cos of 180 is just minus 1, right? And then plus Fg parallel is mass times gravity, which is the mass is 5, the gravity is 9,8. Since this is the opposite side of the angle 32, I'll use sin of an angle, which is sin 32, and then change in x. Don't forget about change in x. Change in x, we've calculated it to be 3. Cos of 0 is 1, right? Now for the sake of the space, let me just move the equal sign over here. That will all be equal to 1 over 2, and then the mass is 5. Right, so now I'm writing the change in kinetic energy. The mass is 5 Vc squared minus Vp. Vp is 1,2 squared. Now let me simplify all of that on the left hand side. On a calculator, it's 10,38 times 3 times minus 1. Okay, that will give me minus 31,14 plus, okay, that would be coming from here, and then plus all of that 5 times 9,8 times sin 32 degrees times 3 times 1. That gives me 77,9. That will be equal to my change in kinetic energy, which is 0,5 times 5. That will give me 2,5. And then times Vc squared minus 2,5 times 1,2 squared. So here I'll get 3,6. Now everything is in terms, I'll write everything in terms of Vc. I'll take the minus 3 to the left hand side so that I'll have minus 31,14 plus 77,9 plus 3,6. That will give me 2,5 VC squared. So let me further simplify the left hand side. I have 31,14 plus 77,9 plus 3,6. The left hand side gives me 50,36. It's equal to the right hand side, which is 2,5 VC squared. Now I'll divide both sides by 2,5. Then I'll get VC squared is equal to 20,14. Then I can put a square root on both sides. Then I'll get a VC is equal to 4,5 meters per second. That's it. So if you like this video, please hit the like button and consider subscribing.